For this final demo, we're going to take what we have learned about C and do something useful and a bit more realistic. Let's combine what we have learned about expressions and statements, functions, structures, and pointers, and design a simple, singly linked list, a container that can act as a queue for arbitrary program data. C is often used for writing embedded system software with severe memory constraints. A good rule of thumb when designing container and other algorithms for such environments is not to assume anything about memory management. Don't assume you can allocate memory. Don't assume your functions can even fail. Keep things simple and keep your assumptions to a minimum, and you'll produce useful and reusable code. A linked list is typically based on the idea that each element in the list contains a pointer to the next element. Let's start by declaring a structure, then, to represent such a linked element. In this case, we cannot simply wrap the struct in a typediff, since the structure first needs to be declared with a reference to itself. Only then can we use a typediff as a convenience to bring its name into the global namespace. Now we'll declare a structure to represent the list as a whole. The list thus simply stores a pointer to the first element as well as the last element. This will allow us to efficiently pop elements off the front of the list and push elements onto the back of the list in constant time. And that's all we need in terms of structure. Now, rather than having our program manipulate these structures directly, we'll wrap up this logic in a set of functions. First, we'll need a function to initialize a list to some well-known state to represent an empty list. The listinit function takes a pointer to a list object as a parameter. It then uses the member selection operator to set the first and last element pointers to 0. This signals to the remaining list functions that the list is empty. It's often helpful to be able to quickly determine whether a particular list is empty, so let's add a function to express that question. The listEmpty function again takes a pointer to a list object as a parameter, and it simply compares the first element pointer with 0, indicating that the list is empty. The return type is bool, and we'll again use the bool typediff. Next, we'll add some functions to walk the list of elements. First up, we can add a listBegin function to return a pointer to the first element. Pretty simple. It just returns the pointer to the first element, stored in the container. Next is the function that returns the next element, an increment of sorts. Unlike the previous functions, this one doesn't need the list itself as a parameter. It simply takes a pointer to an element and returns the next element. Now all we need is a function to push elements onto the back of the list and another to pop them from the front. This is where it gets a little trickier. We'll start with the listPushBack function, which needs to accept both a list and an element. The thing to remember at this point is that the act of pushing an element onto the back of the list is different depending on whether or not the list is empty. We can express this with an if statement. Now we can more easily fill in the appropriate behavior. If the list is empty, then the newly added element is both the first and the last element of the list. On the other hand, if the list is not empty, then we first need to update the last element to point to the new element as its next element, and then set the list's last pointer to point to the new element. Finally, let's not assume that the caller knows anything about the list's implementation, and set the element's next pointer to 0 so that it properly marks the end of the list for safe iteration. And that's it for the pushback function. Now for the popFront function. This function will assume that the list points to at least one element. We can declare it as follows. As you can see, it returns a pointer to a list element, given a pointer to the list container. The popFront function needs to temporarily store a pointer to the first element. It needs to do then some housekeeping, and then return that temporary pointer. This housekeeping involves updating the list's first element pointer to point to the next element. It doesn't matter if there isn't a next element, since it will be 0, and will simply result in an empty list, as you'd expect. Finally, we can return the popped element. And that's it. We should now have a working singly linked list. Let's see how well it works.